So the distributive property, guys, that's what we're doing today. We're starting the new textbook. What I want you to do is we're going to be writing a few notes first, and then we're going to do some example problems. You guys are going to try it. We'll do another example problem. You'll try it on your own, and then that's how it's kind of going to work. So what I want you to do is we're going to make a T-chart at the very, very, very top, and we're going to label. So make your T-chart all the way through, somewhere about halfway. Label the left-hand side what we call arithmetic or arithmetic. So that means on the left-hand side, I'm going to show you what this looks like using arithmetic or numbers. On the right-hand side, we're going to do the exact same thing using algebra. Okay. So we're going to start with arithmetic and algebra. Okay, so here's the first thing you guys are going to write down. 4, and I'm going to use color so it can help you see a little bit better. 4 times 20 plus 6. Okay, 4 times 20 plus 6. How many of you guys have heard of the distributive property before? Okay, so how many of you use the arrows to make sure that you draw it in? All right, good. Distribute means to give something to everybody. So if I were to ask Logan to distribute the Unit 1 homework log, what would he do? He would give 1 homework log to everybody, right? So here's how the distributive property works. You multiply the 4 times the 20, and then we add 4 times 6. And I do want you to show all those steps at first, okay? So 4 times 20. And then we add the 4 times the 6. So that's how you're going to be showing your work at first. And this is just so that I know that you understand, okay? So 4 times the 20 plus the 4 times the 6, right? We're not even going to worry about solving it right now. I'm just showing you kind of how it works. What does this look like in terms of algebra only? So when we do this in algebra, to rewrite it, we rewrite the concept using letters only. So let's give 4 the letter A. So this would be the same as saying, if I wanted to multiply A times B plus C, that would be the same as A times B plus A times C. You guys okay with that? Yes. So in algebra, what we do is we write out a concept using variables only, because these could actually stand for any number at all, right? Okay, something you may not have seen before is, what if I want to rewrite this distributive property, but I reorder things? So let's say 20 plus 6 times 4 on the back. How does that change things? The 4 is in the back. Does it change the distributive property at all? No, we can distribute from the back. Okay, so that would be the same as saying 20 times 4 plus 6 times 4. So we would just put the 4 in the back. Okay, but it's the exact same. But you are going to see problems written like this, so I just want you to be able to do so. So what I want you guys to do right now is see then if you can figure out how to rewrite this on the right-hand side using algebra only. So hopefully you gave the same letters to the numbers. If you didn't, it's okay, but what we should have got was B plus C times A is the same as B times A plus C times A. Everybody good? Okay, great. So we're going to do a couple of examples. And what I want you guys to do is leave a little bit of space, like maybe 2 lines, because we're going to write something else down here, but we're not going to worry about it just now, okay? So leave a few lines, and then we're going to go right into example 1. So here's example 1. I'm going to do 2 parts, part A and part B. So part A is 3 times x plus 8. And your instructions there are going to be to simplify. Simplify. So there's your first example. 3 times x plus 8. Here's how I want you to show your work. So what I see right now is a distributive property. So I'm going to distribute the 3. So I want you to draw the arrows so I know that what you're doing is multiplying. And I want you to write all the steps out. So this is the same as saying 3 times x plus 3 times 8. And then we actually want to multiply it all out. 3 times x gives me 3x plus 3 times 8 gives me what, guys? 24. Box that as your answer. Okay. So then what happens if you have a negative? That's what I want you guys to look at next. So part B. And I'm going to put it in the back this time. So part B, your instructions are simplify. I'll actually write the simplify this time. 5b minus 4 times negative 7. So I put a negative in there, and I also put the distributive property in the back. So here's what I'm going to do. I'm going to draw my arrows, and then I'm going to write it all out. Okay. Now, really quick, guys, subtraction is the same as adding a what? Adding a negative. So, are you comfortable with me splitting it up into this as being 5b plus negative 4, or are you okay just leaving it as minus 4?
I don't care.
You don't care? Leave it as the way it is? Okay. So here's what we're going to do. 5b times negative 7 minus 4 times negative 7. So what does that give me? 5b times negative 7. Negative 35b. And then here's where it gets tricky. Is this 4, is it a negative 4 or a positive 4? It's actually a negative 4 because there's a negative attached to it. So what's negative 4 times negative 7?
28.
Positive 28. So make sure you change it to plus 28 and box it for me.
Yes.
Okay? So far so good?
Yeah.
Okay, so here then is where we're going to go into our textbook. So look at your textbook and then turn to page 4. So see page 4 where it says problem 1. I just did the examples from problem 1, but they're not in your book, but they're in your notebook. And then underneath it says got it, right? You guys see that?
Yes.
Okay, there are 4 problems here with space for you to write that are similar to the ones I just did. These are a little bit trickier than what we just did, but that's okay. I want you to try them anyway. So I want you to try A, B, C, and D for me. Simplify by multiplying. In your book, you can work with the person next to you. I'm going to give you 5 minutes till 9:25. Okay, so really quick, on part A, you should have distributed the 5, and that would give you 5x plus 5 times 7. So 5 times x plus 5 times 7. And that gives you 5x plus 35. How many of you got that? Excellent. Okay, make sure you box your answer. On the homework, I want you to box your answer. Sorry. If you want to highlight it, that's fine too. Okay, part B was a little trickier. You distribute the 12, and that gives you 12 times 3 minus 12 times 1/6t. So all of you should have been able to get to there. 12 times 3 gives me 36 minus, okay, what's 12 times 1/6?
12/6.
12/6, which reduces to? 2. So minus 2
Negative
t.
2t.
2t. If it's 2, I do not want you to write 2/1. If you, after you reduce to something over 1, leave it as 2. Okay? If you showed the extra step of 12/6t and then did the reducing in your answer, that's great too. So 3 steps is great. Okay, part C. When you multiply, that gives you 0.4 times 3 plus 1.1c times 3. 0.4 times 3 gives us what, guys?
1.2.
1.2. Plus 1.1c times 3 is? 3.3c.
I see.
Everybody good? Okay. And then last one. This is going to be 2y times negative y minus 1 times negative y. What's 2y times negative y? Who got that? Negative 2y squared. And then negative 1 times negative y gives me plus y. And that's your answer. Okay, so when we add to our T-chart, I want to talk about fractions a little bit. If I give you the fraction 7/10, that is the same as saying 7 times 1/10. Do you guys agree?
Yes.
Okay, so let's write that in algebra. A over B is the same as saying A times 1/B. You kind of already did that in part B in the practice ones that you just did. But I want you to actually have it written down because the next example is going to be a whole bunch of numbers over one single fraction. So here is example 2. Simplify 7x plus 2 over 5. Okay, simplify 7x plus 2 over 5. Okay, so here's how we're going to do it. Everything in the numerator is your A. So like we just wrote in the T-chart, I'm going to scoot it down just a second. Everything in the numerator is A. So 7x plus 2 is the A term. The B term is just 5. So let's rewrite it as a fraction times the A term. So we can rewrite that as 1/5 times 7x plus 2. Why would I do that? Because now I can use the distributive property. Okay? So using the distributive property, I get 1/5 times 7x plus 1/5 times 2x. Or, sorry, times 2. And then the last thing I want to do is multiply. 7x is the same as 7x over 1. So when we rewrite it, it would be 7 over 5x, right? Plus 2 over 5. And that's going to be your answer. Is it okay that I did not put the x in the numerator? Yeah, it is, because with multiplication, order doesn't matter. So if I'm dividing the 7 by 5 and then multiplying by the x, it's the same thing. Okay, so that's how you're going to be rewriting it. So now, under example 2 in your book, so under problem 2, I want you just to do parts A and B for me. My question is, what is the first thing you did? So, the very first step in part A, what did you do? Who's in 36? Darren, what did you do first? Okay, so 1/3 times what? 4x minus 16. So here's kind of what we're doing, guys. We take out the denominator because that helps us be able to then use the distributive property. So good, that's perfect. And then what did you do next? Who's 23? Okay, what did you do next? You don't have what? Okay, then you need to share with Zach. So then, Zach, what did you do next?
And I did the arrow.
Okay. So then he distributed, and that gives us what? What did you write down next?
1/3 times 4x plus 1/3 times -16.
4x, and then you split this up as plus 1/3 times negative 16? Is that correct, guys? Yes. How many of you just did minus 1/3 times 16? Did anybody do that? Is that still correct? Yes, it's the exact same thing. Excellent. Okay, and then the very last step is what you got for your answer. What did you get for your answer? Who's in 5? Logan.
I got 4/3x minus 16/3.
Minus 16/3. Can 16/3 be reduced, ladies and gentlemen?
5 and 1/3.
No, you cannot, so you leave it just like this.
Numbers, no.
Leave it as an improper fraction. Okay? Excellent.
I don't care.
You guys good?
Yes.
Okay, then I'm going to do part B for you really quick. We pull out 1/6, just like we did in part A. That leaves us with 11 plus 3x. And then we distribute. So that gives me 1/6 times 11 plus 1/6 times 3x, which gives me 11/6 plus 3/6x. Can I reduce?
Yeah.
Yes, 3/6 reduces to 1/2, so 1/2x, and that is your answer.
Yes.
You do have to reduce it. So if you forgot, make sure you do it now.
Always reduce.
All right, then example 3. So back to your notebook. Simplify negative times 2y minus 3x. Guys, if I have a negative by itself, what's actually there? 1. So I want you first to write in a 1 in there. Eventually it's going to be where you don't need to write it, but for right now in our notes we want to. And then distribute the negative 1. So what would this look like? Negative 1 times 2y minus negative 1 times 3x. If you want to do plus negative 1 times negative 3x, that's great too. It's the same thing. So this gives me negative 1 times 2y is negative 2y minus negative 1 times 3x. So minus negative 3x, which actually turns into what? Plus 3x. So negative 2y plus 3x.
Yeah.
Okay?
Everything and everyone.
So under problem 3 in your book, just do A and B for me really quick. All right, so for part A, first thing I want you to do is draw in the negative 1, and then you're going to do what? Who was in 19? Tim, then what'd you do?
Then you have to basically distribute.
Distribute, good. So that should give me negative 1 times A plus negative 1 times 5, and that gives you what as an answer, Anastasia?
It's going to give you negative 1A.
Okay.
5.
Plus 5? Minus 5. Guys, question. When Anastasia read her answer, she said negative 1A, but I wrote just negative A. Are those the same thing?
Yeah.
Yes. Okay? And what I would like you to start doing is getting used to, if the coefficient is 1, to just writing the negative or not putting it at all. Okay? So if you wrote negative 1A, it's not wrong, but write this underneath just so that you start getting used to it. Okay? Same thing for part B. So we distribute. And that's going to be negative 1 times negative x plus negative 1 times 31. And that should give you an answer of positive x minus 31. How many of you got that one correct?
Yeah.
Fabulous. In your textbook, turn the page really quick. The next one is using mental math with distributive property. I'm going to skip that, and we're going to go straight into problem 5, combining like terms.
Yay, wait, where's that at?
Okay, so it's on actually page 7.
It says problem 5, is that actually?
Yeah. So example 5, we are going to combine like terms.
Okay, this is what I was talking about.
Okay? Okay, so We actually do have new vocabulary, which I forgot, but we'll add it to our vocabulary page tomorrow. Like terms. Like terms are terms that have the same variable and the same exponent. Okay? So example 5, there's going to be 2 parts. Part A, 8x squared plus 2x squared. Okay, here's what I do with like terms. I circle all of the terms that are the same, and then I use like a box to do all the other terms that are like terms, and so on and so on. In this case, we only have one type of term. We have an x squared and an x squared, right?
Yeah.
So are those like terms?
Yeah.
Yeah, so here's what we do. When we add them together, we add the coefficients, and then make sure we put that like term at the end, because this is the same as saying 8x squared, so I can write x squared 8 times, plus 2x squared. So how many x squareds do I end up with? 10x squared.
What?
No, because we're just combining them. We're just adding them together.
Exponents don't come out. Show your work.
So with exponents, if we are adding, the exponent stays the same. The exponent changes when we multiply. Okay, so that's why we're going to do another example. So part B.
Part B.
5x minus 3 minus 3x plus 6y plus 4. So I have several different types of term in this problem. Yep, several different types. I have x's, I have y's, and then I have just plain numbers.
That's a big problem. 4, 6.
So here's what I want you to do. Let's box all of the x terms. So I have a 5x. If you want to triangulate them, that's fine. What else belongs with the 5x? Okay, I'm hearing 2 things. 3x and negative 3x. Do we have to connect that negative to the 3x? Yes, so make sure you put a box around the negative 3x.
Yeah.
Okay, then we also have y's. I'm going to circle the y's, and it's a positive 6y. Are there any other y's in there? No. And then I'm going to underline all the numbers. So I have a negative 3 and a positive 4. So now let's combine these. 5x minus 3x gives me 2x. I'm going to put the y's after, so then we just have plus 6y, because you can't combine it with anything. And negative 3 plus 4 gives me positive 1. That is my answer.
We're gonna do the examples in the textbook.
Okay?
Can you do all of them?
So problem 5, do all 3 examples for me. I'm going to go over this. Okay, guys, here are the answers. 3y minus 1y gives me 2y. Negative 7, mn to the 4th, minus 5, mn to the 4th. These are like terms because they both have mn to the 4th. So that's going to give me negative 12, mn to the 4th, because both of these terms are negative. And then the last one, I have 7y to the 3rd z and 1y to the 3rd z. Those are my like terms. Those give me 8y to the 3rd z. And then I have minus 6yz to the 3rd. So the variables need to be exactly the same in order for them to be considered like terms.